Hey, what's up guys? Mr. Bella here. What we're going to be learning today, find the area of a parallelogram and find missing dimensions of that. So let's talk about like what the uses of finding areas of parallelograms are. One thing that I can think of first of all is painting, like the area of your house. If you're painting the inside or the outside of your room or your house, you're dealing with parallelograms. Maybe you're thinking, hey, what? No, I have rectangles in my house. So there we have it. First part of this lesson is what is a parallelogram? So by definition, parallelogram is a type of quadrilateral. Quadrilateral has four sides. So here we have polygons enclosed by straight lines. Then you have a quadrilateral, four sides. Within all the quadrilaterals, you can just have whatever, just four sides. Specifically a parallelogram though, just like the name implies, it has parallel sides opposite. So most people, when they think of parallelograms, they think of drawing it this way. So by definition, it has the opposite sides are parallel. Okay, so this is parallel with this side is parallel with this side. So when you're saying, oh, but what about my room? They're all rectangles. So technically all rectangles are also parallelograms, because if you have just a regular old rectangle, this is parallel with that side and this side is parallel with that side. So it's technically a parallelogram. Okay. It just so happens that it also has four right angles. So finding the area of a parallelogram, same as finding the area of a rectangle in a way, but you'll see. So I have some paint here. Let me turn on my camera so I don't have to mess with anything else. I'll put this on automatic. So good old bucket of paint, Bare Premium Plus and all-in-one. And on the back, and you're gonna see this on most paint cans, it's going to give you the coverage, the square feet coverage. And in this case, it says 250 to 400 square feet of coverage. That's how many square feet you can cover with this gallon of paint. And in this case, so here we have also Bare Premium Plus Ultra Paint and Primer in one. Okay, and let's look for the coverage here. It's kind of messed up because, it's old. It's just been sitting in my garage. And here it's 60 to 100 square feet of coverage. 60 to 100 square feet of coverage. Okay, so why is that gonna help? Well, paint isn't that cheap, so you're not gonna wanna buy too much of it. Two, when you get paint, unless you're getting like just flat white, you're mixing the color in there. That's one of the ways you can use it. You would find the area of all the walls in your room. Let's say you want to redo your room. You've been bored in the house. You're in the house bored. You want to put an accent wall on one of your walls. Just one of your walls, you want it to be like some kind of green or something. Well, is a cord going to be enough? Does that look like enough? Well, you're going to have to find out if your wall is going to be between 60 and 100 square feet, and then see you're going to want to have probably two coats on there. So is that going to be enough? Is it a small wall? Is it a big wall? If you're going to paint your entire room, is 1 gallon going to be enough? You have to make sure before you head over to Home Depot or Lowe's or something and kind of waste your time. Right? So it's just one example of where area could be important. And then we're going to get to surface area pretty soon. And that's exactly what that is. Moving on to this, to find the area of different types of polygons, and we're going to start off with this chapter just doing parallelograms, and that includes squares and rectangles. Okay, so what is area? Area is a two-dimensional measure that describes the number of square units within a bounded region. So exactly what that means. The number of square units. So it doesn't say this is 4 inches on this side or 4 centimeters or 4 feet. Let's just say it's inches for the sake of it, inches. So that means each one of these little squares is 1 inch by 1 inch. So the area is how many 1 inch by 1 inch squares do you have in this figure? Okay, so same with the rectangle. How many are there? So with the square, 16. There are 16 little square, 16 little squares that are 1 inch by 1 inch. But that's also written in 16 inches squared like that. Same as this. This rectangle is 3 over here by 5. There are 15 of these, and it's still inch by inch. So there are 15 little squares that are 1 inch by 1 inch. So that's why we call it square inches, not just inches. Inches is the length. Okay, so now let's kind of review perimeter and area for the squares. And since there's 4 s's here, that's exactly what it is, 4 times s. You could do s plus s plus s plus s, but multiplication is just repeated addition, so there you have it. For the area, you just have side times side, which is why it's the same thing as side squared. So that's area is the same as side squared. For a rectangle, also you might have known this was W also, and this is length. So if you add them all up, that's 2 lengths plus 2 widths. That's why you have 2L plus 2W. For area, that's just going to be length times width. As we saw from the previous example, you just multiply the 2 sides. We counted them and got 16 and 15, but you could have just done 4 times 4 or 3 times 5. So that's what we have it. For parallelogram, this is the interesting part. A parallelogram, we can kind of look at the area of a rectangle, and so like you're like, oh, but it's slanted, they're not going to be like exact squares. So to make any parallelogram, you can have a rectangle and slice off the side and put over there. So let me show you what this picture is talking about here. So, whoops. So let me show you here. What I'm saying is this rectangle, the rectangle that we just had above, if I sliced it down here and I took off this triangle and I moved this triangle over there, the area should be the exact same. But now you actually have a parallelogram. You have this figure here. But the area should be the same because I just took this area over here and I moved it over to the other side. So the area should be the exact same. So how that's shown is we're not going to call it length and width anymore. We're going to call the bottom part, or just one of the sides, we're just going to call that the base. Okay? And then perpendicular to the base, now if you forgot what perpendicular means, it's at a 90-degree angle. Perpendicular to the base, we're going to call that the height. And that is what the width was for this rectangle. So this is the height, this is the base, and if you multiply those two together, your area will equal base times height. That's why it's the same as length times width. You just multiply the two. You actually have an extra side here. We'll call that A, right? And this would also be A, and this would also be B at the top. So to find the perimeter is actually different now. The perimeter is you add up the outside. So the H there is not going to be used. It's going to be 2 times A plus 2 times B in this case. So you add up this and this, and this and this. You just add up all the sides on the outside. All right, hopefully that made sense. And we'll move on to like triangles and stuff in the next lesson. So some very simple ones here. Find the area of the parallelogram. Base is 6, the height is 8. So this right here is 6. The height, see, I almost made a mistake. That's not the height. The height is 8 over here. And maybe before you could count the little squares, like 1, 2, 3, 4, 5. I'm not going to do that. Because you could just multiply. The area is going to be the base times the height, which is 6 times 8, so 48. And make sure you don't forget the units. It doesn't say units, but still, it's units squared to show that you know that what you're talking about, that it's actually area. All right. So here, it's 8 times 6. If you actually did count up all of these boxes, you would have 48. Like 1, 2, 3, 4, 5. And then this, you would probably match it up with this box over here, down at the bottom. Like this and this would make 1. If you were meticulous enough to do that, you would end up with 48 exact little squares. This is 1, 2, 3, 4. So this is 4, and then the height, again, don't look at the slanted parts. That's not the height. The height is perpendicular to the base, so at a 90-degree angle. So here, 1, 2, 3, 4, 5. This is 5. So your area is, the base is 4 times the height is 5, so 20, and then in this case, units squared. So make sure you're counting that this from here to here is 1, 2, 3, 4. I still see some people trying to count like the lines, like 1, 2, 3, 4, 5. That's not how we're counting this. We're counting like how many inches are there if this was an inch, right? This would be from here to here is 1 inch, 2 inches, 3 inches, 4 inches. Okay, that's how you would count. All right, sometimes the height is not shown inside of the parallelogram. So like here, the height is 11 centimeters. So that's the hard part, is to know what the height is. You're gonna, maybe your eyes are gonna go to the 13 and go, okay, I wanna use the 13. The 13 is this part. That's not gonna be used for the area. That's gonna be used for the perimeter. So your height is 11. So your area is equal to the base times the height, and that's going to be 20 times 11. Okay? You have 220. And this is centimeters, so centimeters squared is your area. It was given on the outside. If I actually measured from here to here, this is the same thing. This is also 11. And that totally makes sense because the distance from here to up here is 11, so that means here to here is also 11. Okay, so that's one part where you have to find out the area. Easy enough. Sometimes you're going to be given the area and you're going to want to know what the height is. So missing dimension here. So if you're not sure what to do, at least write out what the formula is. Area equals base times height. So figure out what we know. So we know that the area is 45 inches squared. So where the A is, stands for area, I'm going to write 45. The base, now, you might look at this and go, oh, the base is 45 because it's on the bottom. Not necessarily. The base is just perpendicular to the height. So the base you might think is this, but that's the same as up here. So the base is 9. And the height is, I don't know. That's what we're looking for. So leave that as h, or you can put it as x or whatever. So now we're back to a one-step equation. To solve for h, I'm going to divide both sides by the coefficient of h, which is 9. So 9 over 9 is just 1, so 1h. 45 divided by 9 is 5. And then our units are in inches. So 5 inches, because that's how tall it is. It's not 5 inches squared. 5 inches squared would be if the area of something. There's not like 5 little squares in there. This is 5, like 1, 2, 3, 4, 5. That's how long or how tall this parallelogram is. Okay, and then similarly this one, a little faster. Area equals base times height. Right now we know that the area is 21 centimeters, so I'm going to put that where A is. The base, that's what I don't know, and the height is going to be 7. That looks like a little sloppy, but I mean, if you really want to rewrite it, 21 equals 7b. To solve for this, you do the opposite of multiplying by 7, you divide by 7. So 7 over 7 is just 1b. 21 divided by 7 is 3. And again, it's centimeters without squared, because it's just 3 centimeters is the base. Okay, so my camera battery ran out, so now I'm doing it just on the iPad here. So Ramila is painting a replica of the national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. So same thing, you need to find the area equals base times the height. Okay, so the base here, that looks like 3 3/4 of an inch, right? So that's fine. Or sorry, 6 3/4 of an inch times the height. So the height is how far is it from here to the top over here, but perpendicular. So if I go from here to here like a perpendicular line, well, this line here looks the same as this line. So what I can do is just go times 12, because that's the height. So now you just have to multiply those two together. If you forgot how to multiply, you make these into improper fractions. So this is, so 4 times 6 plus 3 is 27. over 4 times 12, all right, over 1. So I'm not going to multiply 27 times 12. I'm actually going to cross cancel here. This is 1 and 3, and now I just have to multiply 27 times 3, which I think is 81. So 81 inches squared. All right, so that's about it. Hopefully that helped, and I'll see you guys next time.